So first off, we're going to talk about some formulas for volume. And basically, in order to find the volume of a three-dimensional object, so we've moved from two-dimensional objects with perimeter and area, and now we're talking about three-dimensional objects and volume. So keep in mind that volume is the amount of water, the capacity of a three-dimensional object. So looking at the formula sheet, the very first formula is for a sphere. Okay, this was the best formula sheet that I could find. And the formula is for volume is 4/3 times power cubed. That second figure is called a prism, a rectangular prism. And the volume is the length times the width times the height. That third figure you see is a cylinder, and the volume of the cylinder is pi times the radius that should be the radius squared. The volume equal to pi times the radius squared times the height. All right, and that's for a cylinder. So I'm going to have to find a different formula sheet. Okay, that's not the right formula. All right, so the volume of a cylinder is pi times r squared times the height. We don't deal with the triangular or the triangular prism. However, we do deal with the cone. So the volume of the cone is 1/3 times pi times r squared times h. And then last is, it could be a square base pyramid or a rectangular pyramid. And it is the length times the width times the height divided by 3. Okay, so there is a mistake on the formula sheet for the cylinder. Now, when you talk about volume, in essence, the volume of any figure is basically the area of the base, and you'll see that as capital B times the height. So the volume in general is the area of the base, which in some instances you're going to see as capital B, and I just understood for the area of the base times its height. So as you take a look at all of these figures, so if you take a look at the prism, in order to find the volume, you're basically going to take the area of the base, right? So remember, the area would be the length times the width, and you're going to multiply it by the height. To find the volume of a cylinder, you're going to find the area of the base. So notice that this thing has a circular base, and the area of a circle is pi times the radius squared, and then you're going to multiply by its height. Okay? And that's going to be true for the volume of any shape. You notice that the cones and the pyramids, things that have like a triangular shape to them, they are multiplied by 1/3. And then our volume for a sphere is 4/3 times pi times the radius cubed. All right, so let's take a look at some of these formulas in action. So this is from section 4.4, and this would be similar to your number 1. And it basically says find the volume of the figure. Now, this is actually a cube. And on the formula sheet, we actually see a rectangular prism. A cube is a three-dimensional object in which all sides have the same length. So in this case, in order to find the volume, we're going to multiply the length times the width times the height. So the length is 2, the width is 2, and the height is 2. So if we multiply all those things together, we're going to get 8. And since volume is measured in cubic units, it's going to be cubic feet. Okay, so volume is in cubic units, area is in square units, and perimeter is in the unit alone. All right, so that would be similar to your number one, just a cube. For problem number 3, we're asked to find the volume of the figure, round to the nearest hundreds if necessary, and this figure is not drawn to scale. So for this particular figure, we're going to break it up into 2 shapes, right? So there's a couple ways you can break this up, but I'm actually going to split it here. And we're going to find the volume for the first shape, and then we're going to find a volume for that second shape. All right, so we're going to find the volume on the first shape, the volume on the second shape, and then we're going to add them together to get the total volume. So as we take a look at the first shape, right, V1, we need to know the length, the width, and the height. So now as I look at the figure, I'm given that the width of this thing is 4. If I'm trying to find the length, notice that if I look at the second figure, the length for both of these figures should be the same. So since the length of the second figure has the same length as the first figure, right, the length is going to be 8 meters. And now I have to figure out the height. All right. So as we figure out the height, notice that this entire height is going to be 6 meters. Right. So this is going to be 6 all together. However, if we take a look at the second figure, its volume, or the height of its volume, is 4. And I'm trying to separate this out as far as the figure. So that means the height of the first object would have to be 2, right? Because 2 plus 4 is going to make 6. So that's going to give me my height, which this height is 2 meters, and that makes this height 4 meters. So in order to find the volume of the first figure, we're going to take the length times the width times the height. So the length is going to be 8. The width is going to be 4. And the height is going to be 2. So we multiply those together. 8 times 4 is 32. 32 times 2 is going to give us 64. So I'm just going to forego the units and put our units on last. All right, so now we're going to find the volume for our second figure. So we know that the length is going to be 8 meters. The width is going to be 11 meters. And its height is going to be 4 meters. All right, so 8, 11, and 4. So if we multiply all these things up together, 8 times 11 times 4 should give us 352. Now, in order to find the total volume, we're going to add V1 plus V2. So 64 plus 352 should give us 416 cubic meters. So we had to split that object up into 2 objects. All right, any questions about number 3? I believe there was another one on there, and you had to do the same concept, split it up into. I believe that when you split it up into 3 shapes. Okay, for number 6, we're asked to find the volume of the cylinder. We're asked around to the nearest hundreds. So the correct formula for volume is the volume is equal to pi times the radius squared times the height. We want to substitute pi for 3.14. So even though it doesn't specifically say that in the problem, we're using 3.14 for all of our pi measurements. So 3.14 times, well, the radius is 3, and then the height is 5. I'm just going to put that all together. So this is 3.14 times 3 squared times 5. I'm just going to simplify it a little bit further. If you use the order operations, please excuse my dear Aunt Sally. The next thing I'm going to do is evaluate my exponent. So 3 squared is 9. So I'm just going to simplify that down to 9. And if we simplify 3.14 times 9 times 5, we get 141.3 cubic centimeters. All right, so basically just plugging and chugging into the formulas. Number 8, they want us to find the volume of the sphere. So the formula for the volume of a sphere is 4/3 times pi times the radius cubed. And in this case, we're going to substitute the radius for 8. So this is equal to 4/3 times 3.14 times 8 to the 3rd power. So now this is actually how I'm going to put this into the calculator. We can basically take any number and put it over 1, which changes into fractions by definition. So whenever you're multiplying fractions, you can multiply the numerators. So in the numerators, we have 4 times 3.14. And if we simplify 8 raised to the 3rd power, we have 512 divided by 3. I'm going to simplify my numerator. So I'm going to multiply 512 times 3.14 times 4. And we get 6,430.72 divided by 3. And now I'm going to divide by 3. And we get 2,143.57 cubic feet. So I basically changed everything to a fraction, right? I just put 3.14 over 1 and 8 to the 3rd power over 1. I multiplied my numerators, multiplied my denominators. And lastly, I divided by 3. All right. So that's problem number 8. Problem number 10, we are dealing with a cone. So the formula for the volume of a cone is 1/3 times pi times r squared times h. And we're going to substitute in the radius as 2.3 and the height as 7.8. Okay, so we have 1/3 times pi, which we're using as 3.14, times 2.3 squared times 7.8. So 3.14, 2.3 squared, and 7.8 all have an understood denominator of 1. All right, so I'm going to multiply my numerators. So I have 3.14. I'm going to take 2.3 and I'm going to raise that to the second power, which is 5.29 times 7.8. And we're going to divide everything by 3. So I multiply all my denominators. 3 times 1 times 1 times 1 is 3. So if we simplify the numerator, 3.14 times 5.29 times 7.8 gives us 129.56268. All right, divided by 3. And once we divide by 3, we have 43.19 cubic centimeters. Okay, so for section 4.4, right, just basically plugging and chugging with the formulas. All right, now in section 4.5, we are dealing with what are called similar triangles. And we're asked to set up a proportion in order to find an unknown side. Okay, so this requires a little bit of algebra. And whenever you are solving a proportion, and I believe we've done this before in the class, we use that cross product property. So again, to solve proportions, we use the cross product property. Okay. And yeah, we use this cross product property when we were dealing with percent equations. So a proportion is just two fractions set equal to each other. So the cross product property says if A over B is equal to C over D, right? So that's two fractions set equal to each other. Then we can cross multiply. We can cross multiply A times D and set that equal to B times C. So we're going to set up these proportions and we're going to use the cross product property to solve. All right. So if we look at the first one, it says for the pair of similar figures, set up a proportion in order to find the unknown sides. Okay. Now there's a couple ways you can actually set up these proportions. So the way that I'm going to set up my proportions are, I'm going to use one triangle and I'm going to set up my proportion according to the corresponding sides of the other triangle. Now we're going to talk about triangles in the next section, right triangles. But as far as the triangle is concerned, notice that these are right triangles. And in a right triangle, the side that's opposite the right angle is your hypotenuse, and the other two sides are legs. So I'm going to set up my first proportion with this first triangle. And the leg 6 is to the leg H, right? So I'm putting this leg over this leg. So on my second triangle, I want to find those corresponding sides. So I want to set that equal to this leg 4 over 6. So that's one way I could set it up. So 6 is to H as 4 is to 6. So notice that our legs for both of these proportions are corresponding. So now I can cross multiply. I can cross multiply 6 times 6, which is 36. I can set that equal to H times 4, which is 4H. And now I can solve for H. Right? The opposite of multiplying H by 4 is to divide by 4. So I can divide both sides by 4. So I'm going to divide 36 by 4. I'm going to divide 4H by 4. Notice on the right-hand side, the 4's cancel, and I'm just left with H. And 36 divided by 4 is 9. So the missing leg on this triangle, H, should be 9. All right, let's look at number 2. Excuse me, the second example, which is actually similar to your problem number 8. It says a tree casts a shadow 38 feet long, while a 6-foot man casts a shadow that is 4 feet long. How tall is the tree? And we're going to use a proportion to solve. So I'm going to actually write out some units for this one. So I want to take the shadow cast, and I want to divide that by the height of the object. So when I set up my two proportions, for my first proportion, I'm looking at the gentleman here standing. I'm going to take the length of his shadow. I'm going to put that in the numerator. I'm going to take his height. I'm going to put that in the denominator. I'm going to do the same thing with the tree. I'm going to take the length of the shadow cast by the tree, and I'm going to put that over the tree's height. Okay, so this is sort of a guide that I'm going to use. So when I set up my proportion, and if we look at the gentleman here, the shadow that he casts is 4 feet, and his height is 6 feet. So that's my first fraction, 4 over 6. If we take a look at the tree, the length of the shadow that the tree casts is 38. So notice in my numerator, I'm only putting the length of the shadow cast by the object. In the denominator, I'm only putting the height of the object. So we don't know the height of the tree, so that's going to be our variable x. So now we're just going to cross multiply and solve. I'm going to cross multiply 4 times x. That's going to give us 4x. I'm going to set that equal to 38 times 6, which I believe is 228. So 38 times 6 is 228. Here again, we want to solve for x. So the opposite of multiplying x by 4 is to divide by 4. So I'm going to divide both sides by 4. When I divide my left-hand side by 4, the 4's cancel. I'm left with x. And 228 divided by 4 should give us 57. So the height of the tree is 57 feet tall. All right, so any questions about number 8? All right, let's take a look at one more. This would be similar to your number 14. And it says, for the pair of similar figures, set up a proportion to find the unknown. Okay, so I'm going to use corresponding sides of congruent triangles. So here again, there are many ways to set this up. Okay, so I'm just going from one figure to another, to the corresponding sides of the other figure. So if I look at my first figure, 1, 2, 3, 4, 5, 6, that's a hexagram. So I'm going to put 50 over 40. Okay. And I'm going to set that equal to 40 divided by j. So I'm taking the corresponding sides of congruent triangles and setting them equal. So I'm taking 50 over 40. I want to set that equal to 40 over j. And now we want to solve for j. So we're going to use the cross product property to multiply. So 50 times j is 50j. I'm going to set that equal to 40 times 40, which is 1600. Now we want to solve it for j. So the opposite of multiplying j by 50 is to divide by 50. Okay, so we're going to divide both sides by 50. On the left-hand side, the 50 cancels, so we're left with j. And 1600 divided by 50 should give us 32. So the missing side length j has a length of 32. All right. So in 4.3, we're using that cross product property, and then we're using the congruent sides for shapes to set up our proportion. All right, now 4.6 is a little bit different. It actually gets into some right triangle trigonometry. So before we begin 4.6, and I passed out a couple of documents, we're going to talk about a right triangle. So in a right triangle, so notice in a right triangle, you're going to see this box. That little box indicates that that is a right angle. And a right angle is a 90-degree angle. The types of angles, just to review geometry a little bit, you have acute angles, and acute angles are less than 90 degrees. You have a right angle, and a right angle is exactly 90 degrees. You have an obtuse angle, and an obtuse angle is greater than 90 degrees, but less than 180. Okay, 180 degrees. And then we have a straight angle, which is exactly 180 degrees. So those are the 4 types of angles. In a right triangle, you have a right angle, and the other 2 angles are acute angles, right? They would be less than 90 degrees. Here are some triangle facts. The sum of the interior angles of any triangle, not necessarily a right triangle, but any triangle, is 180 degrees. So that means if you were to add up all 3 of the angles of any triangle, they should always sum up to give you 180 degrees. Okay, that's just the fact about any triangle. When you're dealing with a right triangle, so in any right triangle, the hypotenuse is opposite the right angle, or excuse me, it's the side opposite the right angle is the longest side. So in any right triangle, the hypotenuse, which is that side opposite the right angle, that's the longest side in any right triangle. Okay, so just a couple of facts about, first off, about a triangle, and then the second, it was just a fact about a right triangle. All right, so in a right triangle, you have the hypotenuse, and you have 2 legs. All right. So now the hypotenuse in these formulas, we're going to see that as C. And then our legs, one leg is called A and one leg is called B. And from this, we have what's called the Pythagorean theorem. And it says that C squared is equal to A squared plus B squared. So I'm actually going to write this out 2 ways. Okay. C squared is equal to A squared plus B squared. But if you're dealing with hypotenuse, leg, and leg, it's going to be hypotenuse squared is equal to 1 leg squared plus the other leg squared. Now, when we're solving these triangles, we're trying to find these side lengths, we never find C squared, we always find C. So if I were to take the square root of both sides, out pops this first formula. C is equal to the square root of A squared plus B squared. Right, I simply take the square root of both sides. So if I take the square root of C squared, the square root and the square cancel, which gives me C. And if I take the square root of A squared plus B squared, I just have the square root of A squared plus B squared. If I'm dealing with hypotenuse, leg, and leg, the hypotenuse is equal to the square root of 1 leg squared plus another leg squared. So now if I'm trying to find A is going to equal to the square root of C squared minus B squared. If I'm trying to find B B is going to equal to C squared minus A squared. And if I'm dealing with the hypotenuse, leg, and leg, the missing leg length is going to equal to the square root of the hypotenuse squared minus the other leg squared. All right, so here are the formulas. All right. Now I passed out, I'll pull it up here. I passed out this sheet. Okay, you should have this sheet. All right. All right, on this sheet we have what are called the trigonometric functions. There are 6 trig functions: sine, cosine, tangent, and then there are the reciprocals. Cosecant, that's the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Now, on this formula sheet, you see a couple of different formulas. The first formula deals with if you're in a rectangular coordinate system. So in our class, we don't deal with the rectangular coordinate system, right? So where you see y over r and x over r and y over x, okay, we don't use that first set of formulas, but we will use this second set of formulas. It says that the sine of some angle A, that's equal to the side opposite over the hypotenuse. The cosine of angle A is equal to the adjacent over the hypotenuse, and the tangent of A is equal to the opposite over the adjacent. Now, in order to better memorize this, there is a saying that's used, and this is the saying. It's chief Sakatoa. I don't know if you ever heard of that or not, but what it alludes to is that the sine is equal to the opposite over the hypotenuse. The co part of it means that the cosine is equal to the adjacent over the hypotenuse. And the toa part alludes to the tangent is the opposite over the adjacent. Okay. Now we're going to explain the opposite, adjacent, and hypotenuse in a minute. But here's the chief Sakatoa. Here's another saying that could help. Remember this. It is Oscar had a heap of apples. So that alludes to the same thing. So it doesn't really give you the sine, the cosine, and the tangent, but Oscar had is opposite over hypotenuse. A heap is adjacent over hypotenuse, and of apples is opposite over adjacent. Now here's another one I just recently learned last semester. A student told me about it, and it is some old hippie caught another hippie tripping on acid. So the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Okay. Just some ways to help memorize this. All right, so now how is all of this stuff used? All right, so we're going to take a look at okay, here it is right here. Now, I think this is similar to number 1. And this is section 4.6. It says refer to the right triangle ABC with C equal to 90 degrees. So C is our 90-degree angle as shown in the figure, and it's telling us that it's not drawn to scale. So it says use the given information to find the 6 trig functions of angle A, and we're asked to answer them exactly. Whenever you set up any trig function, you must have what's called a reference angle. And so they're giving us that reference angle, which is angle A. So just to denote that angle A is our reference angle, I'm going to put a curvature on angle A. So now if they were asking us to find the 6 trig functions for B, I would put my curvature on B, and that would denote the reference angle. Right? Once you set up your reference angle, you should now label your sides. And let me put some steps. When setting up a trig trigonometric function, the first thing you should do is set a reference angle, and we set a reference angle as A because in the problem we're asked to find the 6 trig functions for angle A. The second thing we need to do is label the sides of the triangle according to the reference angle. Okay, so what do I mean by that? Well, we need to label one side the hypotenuse, we need to label one side the adjacent, and we need to label one side the opposite. So now, from what we know about a right triangle, what side is going to be the hypotenuse? That's the first thing I would always label. To determine the hypotenuse, I would locate my right angle, and the side that's opposite my right angle, that is the hypotenuse. Now that's never going to change. But what could change based on which angle you use is the opposite and the adjacent sides. So I'm just going to abbreviate that as HYP, which is hypotenuse. So now I have my reference angle A. The side that's opposite angle A, that's going to be our opposite side length. So if I look at angle A, which is here, the side opposite angle A is side length A. So A is going to be the opposite. That's my opposite side. My adjacent side is going to be B. So B is my adjacent, and that's adjacent to angle A. Now, two things are adjacent if they share a common side. For example, this room and that room over there are adjacent because they share this common wall, this common side. Angle A and side length B, they share this common side B, so that's my adjacent. All right, so whenever you set up a trig function, first thing you do is set a reference angle. Next thing you do is label all the sides. And then the third thing we want to do is find all side lengths. So now they gave us 2. They gave us that B was equal to 7 and C is equal to 25. How would I find side length A? So in order to find A, I'm going to go back to the formulas right here. And we had a formula for that, right? A is going to equal to the square root of C squared minus B squared. So I'm going to use that. So to find A is going to equal to the square root of C squared minus B squared. We're going to substitute C for 25 and B for 7. So A is going to equal to the square root of 25 squared minus 7 squared. So if we square 25, we get 625. So now this is still all under the square root, so we don't cancel the squares. So I'm squaring 25, we get 625. And 7 squared is 49. The next thing I'm going to do is subtract. 625 minus 49 is 576. And now I'm going to take the square root of 576, which is 24. So side length A is 24. All right, so any questions on, first of all, setting up your right triangle, right? You have to find a reference angle or set a reference angle, label all your sides, find any missing side length. Now we're going to use the Chief-Sohcahtoa, all right? So we want to find the sine of angle A. So in that Chief-Sohcahtoa saying, the sine is the opposite over the hypotenuse. So the sine of angle A is 24 over 25. The cosine of angle A, that's the chi part of Chief-Sohcahtoa. So the cosine is the adjacent over the hypotenuse. So the cosine of A is 7 over 25. The tangent, that would be the toa part, right? The opposite over the adjacent. So the opposite is 24, the adjacent is 7. So the tangent is 24 over 7. And then we have our reciprocals, right? So we had the Chief-Sohcahtoa, to give us the first 3 trig functions. The other 3 trig functions are reciprocals. So the reciprocal of cotangent is tangent. So the reciprocal means I'm just going to flip-flop the numerator and the denominator. So if the tangent is 24 over 7, its reciprocal, which is the cotangent, is 7 over 24. The reciprocal of secant is cosine. So if the cosine is 24 over 25, its reciprocal, which is the secant, is going to be 25 over 24. And the reciprocal of cosecant is sine. Okay, let me go back. The reciprocal of secant is cosine. Right, the reciprocal of secant is cosine. So if the cosine is 7 over 25, the secant is 25 over 7. Because one way to remember the reciprocals, they don't start with the same letter. So like the cotangent and the tangent are reciprocals. The secant is the reciprocal of the cosine, right? Because they begin with a different letter. That's one way to remember that. The cosecant is the reciprocal for the sine. So if the sine is 24 over 25, the secant is 25 over 24. Right. So that was the very first problem. All right. So now with the time that's left, I want to talk about the unit circle. And then when we meet again next week, we'll kind of go further down the line in the trig world. But I passed out this unit circle. And this is all what's involved. Just kind of explain this to you. So if you look at the unit circle, we have degree measures. So if you look at the far right, notice that you have 0 degrees. And then if you go in a counterclockwise direction, you have 30 degrees. And then you see that pi over 6. That's actually a radian measure, which we don't use in this course. We use degrees. Well, I shouldn't say that. I believe there are a couple of questions that use these radian measures. So 30 degrees and pi over 6 radians are exactly the same. Then we have 45 degrees, 60 degrees, 90, so on and so forth, right? And then we make one complete rotation at 360 degrees, which is 2 pi. Now, the way that you actually read this is in any rectangular coordinate system, you have what's called an ordered pair, right? You have an X and a Y ordered pair. In trig, in the unit circle, the X coordinate is the cosine of some angle, and the Y coordinate is the sine of some angle. So from that, you can evaluate trig function. For example, what is the cosine of 30 degrees? If I wanted to find the cosine of 30 degrees using the unit circle, I would find the 30-degree angle, which is here. Since I'm looking for the cosine value, that's going to be the X coordinate. So the cosine of 30 degrees should be the square root of 3 over 2. All right. If you wanted to find, let's say, the sine of 330 degrees, you would locate 330 degrees in your unit circle, which is this 11 pi over 6 angle. Since the sine corresponds to the y coordinate, the sine of 330 degrees would be negative 1/2. So we get negative 1/2. You can also evaluate these things on your calculator. However, the calculator is not going to give you any square roots. So for example, if you are dealing with a graphing calculator, you have to go into your mode and you have to make sure you have it on degree mode. There's two modes in this. There's a radian mode if you're inputting radian measures, and there is a degree mode. So I have to make sure I'm putting in degree mode because I'm dealing with degree measures. So now that I'm in degree mode, I can put in the sine of 30 degrees. And notice it doesn't give me square root of 3 over 2. Oh, excuse me. I'm going to put in cosine of 30 degrees. And notice it doesn't quite give me the square root of 3 over 2, but it gives me the approximation, right? The square root of 3 divided by 2 should be that same exact value. I can find the sine of 330 degrees, so I can just simply input sine 330, and I should get negative 0.5, which is negative a half.